Hello everyone. Welcome back to my course Aerospace Engineering, Basics of Aerodynamics. In this video, we will talk about the 4 forces of flight. Also, I will be thankful if you give me feedback about this course to make it better and more useful for you. Please write down your thoughts in the comment section or reach out to me via the email provided in my profile. Forces of flight and flight axis. Before explaining how flight controls affect an airplane, it's important to understand the forces involved in flight and the axes that define the airplane's movement. 4 main forces act on an airplane, as shown in the figure below. First, gravity causes the airplane's weight, symbolized by W, which acts downward through the center of gravity. The main aerodynamic forces are lift, L, which acts upward and opposes the weight, and drag, D, which moves in the direction of the flight path. The key to flight is the lift generated by the wings, so understanding the aerodynamic properties of the wings is crucial in airplane design. Lift is produced by the pressure difference between the upper and lower surfaces of the wings. As the airflow moves over the wings, it accelerates over the upper surface, lowering the pressure there compared to the lower surface. This pressure difference creates the lift that keeps the airplane in the air. However, generating lift also results in drag. In steady unaccelerated flight, known as trim, the lift equals the weight of the airplane, and the thrust needed to maintain flight is equal to the drag. This can be expressed as lift equals weight and thrust equals drag. An airplane can also pitch, roll, and yaw. It pitches around the lateral axis, rolls around the longitudinal axis, and yaws around the vertical axis, as shown in the figure. The pilot can create moments around each of these axes by using the flight controls, resulting in a pitching moment, My, rolling moment, Mx, and yawing moment, Mz. Lift and drag are considered to act at a specific point on the wing called the center of pressure, where the pitching moment is 0. This point is often referred to as the neutral point. In steady, level, equilibrium flight, also known as trim, the airplane's net moments about its center of gravity must be 0. This means that there are no unbalanced forces causing the airplane to pitch, roll, or yaw. The lift generated by the wings must exactly counteract the weight, and the thrust must balance the drag, ensuring that the airplane remains in a stable, level flight without any tendency to rotate around its axes. In maneuvering or accelerated flight, the requirement for force and moment equilibrium is not always necessary. Unlike steady, level flight, the forces and moments may not be balanced because the airplane is undergoing changes in speed, direction, or attitude. It's important to note that the origin of the coordinate system used for analysis can be chosen at any convenient point. In engineering practice, different origin points might be used depending on the specific analysis being performed. The airplane's center of gravity is commonly used as a reference point, but it's important to remember that the center of gravity is not a fixed point. It can shift slightly during flight, especially as fuel is consumed and the airplane's weight decreases. A force may be thought of as a push or pull in a specific direction. This picture shows the forces that act on an airplane in flight. Now let's talk a little bit about these forces. Weight. Weight is a force that is always directed toward the center of the Earth. Its magnitude depends on the total mass of the airplane, including its structure, fuel, and any payload, such as people, baggage, or freight. While the weight is distributed throughout the airplane, we can often treat it as if it acts through a single point known as the center of gravity. During flight, the airplane rotates around the center of gravity, but the direction of the weight force always points toward the Earth's center. As the airplane consumes fuel during a flight, its weight continuously changes. The distribution of weight and the position of the center of gravity can also shift, so the pilot must frequently adjust the controls to maintain balance and stability. Lift. To make an airplane fly, we must generate a force to counteract the weight. This force is called lift and is produced by the airplane's motion through the air. Lift is an aerodynamic force, where aero refers to air and dynamic refers to motion. Lift acts perpendicular at a right angle to the flight direction. Like weight, each part of the aircraft contributes to the total lift force, but most of the lift is generated by the wings. The lift acts through a single point known as the center of pressure. The center of pressure is defined in a similar way to the center of gravity, but instead of using the weight distribution, it is based on the pressure distribution around the airplane's surfaces. Drag. As the airplane moves through the air, another aerodynamic force comes into play: drag. Drag is the resistance the air exerts against the aircraft's motion. Like lift, several factors affect the magnitude of the drag force, including the shape of the airplane, the stickiness, viscosity of the air, the speed of the aircraft. Similar to lift, we combine the individual drags from different parts of the airplane into a single total drag force. The direction of the drag force always opposes the direction of flight, and it acts through the center of pressure. Thrust. To overcome drag, most airplanes use a propulsion system that generates thrust. The magnitude of the thrust depends on several factors related to the propulsion system, including type of engine, number of engines, throttle setting, speed. The direction of the thrust force depends on how the engines are mounted on the aircraft. In some aircraft, like the Harrier, the thrust direction can be adjusted to help the airplane take off in a very short distance. For jet engines, it's important to remember that aircraft thrust is a reaction to the hot gas expelled from the nozzle. The hot gas is pushed out the back, but the thrust force pushes the aircraft forward. This is an example of Newton's third law of motion. For every action, there is an equal and opposite reaction. The motion of the airplane through the air depends on the relative strength and direction of the forces shown above. According to Newton's first law of motion, an object at rest will stay at rest, and an object moving at a constant velocity will continue to do so unless acted on by an external force. If there is no net external force, the object will maintain its constant velocity. In an ideal situation, the forces acting on an aircraft in flight can balance out, producing no net external force. This happens when lift equals weight and thrust equals drag. A good example of this condition is a cruising airliner. Although the weight decreases due to fuel consumption, the change is minimal compared to the total weight of the aircraft. The aircraft then maintains a constant airspeed, known as the cruise velocity. To determine the ground speed of a cruising aircraft, we need to account for the wind's relative velocity. Ground speed is the sum of the aircraft's airspeed and the wind speed, vector addition. The aircraft's motion is purely translational, meaning it moves in a straight line. With a constant ground speed, it becomes easier to calculate the aircraft's range, the distance it can fly with a given amount of fuel. If the pilot changes the throttle setting or increases the wing angle of attack, the forces become unbalanced. The aircraft will move in the direction of the greater force, and we can compute acceleration of the aircraft from Newton's second law of motion, F equals m times a. By simplified motion, we mean that some of the four forces acting on the aircraft are balanced by other forces, and we focus on just one force and one direction at a time. In reality, this doesn't happen because all the forces are interrelated with the aircraft's speed, altitude, orientation, and other factors. However, analyzing the forces in isolation can help us understand the basic concepts more clearly and is easier to comprehend. In an ideal situation, an airplane can maintain a constant speed and level flight, where weight is balanced by lift and drag is balanced by thrust. A good example of this is a cruising airliner. While the weight decreases as fuel is burned, the change is relatively small compared to the total aircraft weight. In this case, the airplane will maintain a constant cruise velocity, as described by Newton's first law of motion. If the forces become unbalanced, the airplane will move in the direction of the greater force. The acceleration the aircraft will experience can be calculated using Newton's second law of motion. To apply this, we first need to know the aircraft's mass from its weight, and the force F would be the difference between the opposing forces, lift minus weight or thrust minus drag. With this information, we can calculate the resulting motion of the aircraft. To summarize, if the weight is decreased while lift remains constant, the airplane will rise. If lift is decreased while weight stays constant, the airplane will fall. If thrust is increased while drag stays constant, the airplane will accelerate. If drag increases while thrust remains constant, the airplane will slow down. Okay guys, now let's have a little quiz. The quiz consists of 7 questions. I'll give you 10 seconds for each one, and then I'll show you the correct answer. Let's start with the first question. Question 1. Which of the following is not one of the 4 main forces acting on an airplane? The correct answer is pressure. Question 2. What does the center of gravity represent in an aircraft? The correct answer is the point where the aircraft's weight can be considered concentrated. Question 3. In steady, level flight, which of the following conditions must be true? The correct answer is lift must equal weight and thrust must equal drag. Question 4. What happens when the aircraft's lift is greater than its weight? The correct answer is the airplane will climb. Question 5. What is the primary reason why the aircraft's weight changes during flight? The correct answer is fuel is consumed. Question 6. If thrust exceeds drag, what will happen to the aircraft? The correct answer is it will accelerate. Question 7. How does the ground speed of an aircraft differ from its airspeed? The correct answer is ground speed is the sum of airspeed and wind speed. Unlock the world of aerospace engineering with my other expertly designed courses. In Aerospace Engineering, Basics of Aviation Engines, you'll explore the different types of aerospace engines and how they perform, giving you a strong foundation in the propulsion systems that power modern aircraft. Then, take your knowledge to new heights with Aerospace Engineering, Aerodynamics and Structures, where you'll dive into the design and performance of aerospace structures and their aerodynamic behavior. Finally, expand your expertise with Aerospace Engineering, Avionics and Aerospace Systems, where you'll learn about the critical electronic systems that control and monitor modern aircraft, bridging the gap between engines, structures, and flight systems. Whether you're a student, aspiring engineer, or aviation enthusiast, these courses will equip you with essential knowledge to understand and contribute to the future of aviation. Join hundreds of learners and start building your aerospace journey today. Thank you guys for watching this video. If you have any questions about this lesson, feel free to ask me in the comment section. I will answer as soon as possible. We can continue to the next lesson and learn about what is weight. See you in the next video. Bye.